Alright, hi guys, welcome to this video. In this video I want to talk about first of all the cosine rule. I want to introduce you to the cosine rule, and then I want to discuss one problem. And so let's get started. Okay, so I want to jump to the brush tool. So the cosine rule states that a square is equal to b square plus c square minus 2 times BC 2 times BC cosine of the angle which is included between B and C, which is A. So this is what the cosine rule says, and you will observe that there is a symmetry involved in this formula, as is with every other formula in this chapter, because we are dealing with triangles which are symmetrical figures, so it makes sense that we are going to observe symmetry. And if we know one of these three sets of rules involving three different sides, we can figure out the remaining two sides. So if we know a square is equal to b square plus c square minus 2 times bc cosine of a, we can calculate the same thing for b square. So b square is equal to the squares of the other two sides minus 2 times the product of the other two sides, 2 times a times c, and then that is multiplied by the cosine of the angle included between these two sides, which is b. And similarly you can do the same thing for c square, but this is essentially the cosine rule, and I want you to remember this as well as add this into your toolkit or your virtual memory, as I like to call it. And we are going to be using this along with other results in order to solve problems. So I want to solve one good problem that I found in my book. So let me just write it down here. I'll just add one divider, and I'll make this little bit less in just bear with me 1 second. I like to make this little bit thinner. 4 pixels sounds good. Okay, so the problem is we are given with this the following equation: 2 cosine a. So we are given with 2 cosine a divided by a plus cosine of b divided by b plus 2 cosine of c divided by c. This all left hand side is equal to a upon bc plus b upon ca. So we are given with this equation, and we need to calculate the value of a. In other words, what is the angle a? So let's think about the approach or our initial goal that we are going to set in this problem. So for that we need to refer to our toolkit. Right now in our toolkit we have three results, I think. One is the sine rule, the other one is the projection formula, and we have the cosine rule that we just learned, and I believe we also have the result which related area of the triangle with one of the signs of one of the angles. So in this scenario I think it's best to go with the projection formula, because this equation only involves the cosines and the sides and there's no square term. So let's see what happens when we are going in the direction with our initial goal. So let's take the least common multiple of the first two terms, because I think we are going to see that we can apply the projection formula. So if we do that, we get AB in the denominator, and in the numerator we get B 2 times B cosine of A plus cosine of B, right, plus this term remains still the same, 2 cosine of c divided by c. Now in the first term you will observe that we can apply the projection formula if we take cosine of b along with 1 of b cosine of a, and obviously the other b cosine of a will still be left. So if we do that, I think the space is finished. Let's see what we can do. So let's just write down this. It's going to be equal to, so if we just refer to the projection formula, this will be equal to 1 second, and by the way this is equal to a cosine b, so there's a here, so this whole thing is equal to c plus b cosine a divided by, so all of that divided by ab plus this term, it's still the same. Okay, so let me just I think we are running out of space, so I'll just create a new page here, and oh, we have space above this page, so I'll just remember what we wrote in the last line and then rewrite this. So c plus b cosine of a divided by ab, so c plus a cosine of c divided by ab hello, yeah, I'm just testing the microphone, and then we have plus 2 cosine of c plus 2 cosine of c divided by c, and let me just verify this one more time. C plus b cosine a divided, okay, so this is equal to b cosine of a, so sorry about that, this is equal to c plus b cosine a divided by ab plus 2 cosine c divided by c. Okay, so let's move further. Now we can simplify this. We can divide this one expression into two constituents, c divided by ab plus, this will be cosine of a upon a plus 2 cosine of c divided by c. And now you'll notice that we can do the same thing that we did earlier with these two fractions. If we take the least common multiple of these two and let this remain untouched, we are going to get c cosine of a plus 2 times a cosine of c. And again you will notice that we can apply the projection formula for b here, so this will become, so this will be, and obviously we still have the c upon ab term, so c upon ab plus b plus a cosine c, and I'll need to scroll down a little bit. Just bear with me 1 second. Yeah, b plus a cosine c divided by ac, and yeah, now we can just equate this with what we are given with, and the right hand side of our original equation was a upon bc plus b upon ca. So you will notice that we already have b upon ca on right hand side as well as left hand side, so I'll just cancel these two terms, and no further simplification can happen. So let's just take the LCM of left hand side, or the least common multiple. We are left with abc, and this will become c square plus ab cosine of c is equal to a upon bc. Now we can just cancel bc, and this a will go here and will become a square, and now we are left with this result, which is c square plus ab cosine c is equal to a square. Now at this point we need to reformulate our goal and form a new goal, new sub goal, in order to solve the problem, because there's no need to further simplify, because we are not going to get anywhere. So we need to re-refer to our toolkit and see if we have any formula which is going to be suitable in this scenario. In fact, we have the cosine rule, and it looks very tempting because the cosine rule involves the square two terms, I mean the quadratic terms like a square c square. It also has 2ab cosine of the angle. In this case we don't have the 2, but we do have ab cosine of some angle. So let's apply the cosine rule. So if we do that, you'll notice that first of all cosine c is equal to, so let me write it down, cosine c is equal to a square plus b square minus c square divided by 2ab. This is cosine of c. If you just substitute cosine of c in this equation, let's see what's going to happen. So first of all, notice that we have AB here and we also have AB in the denominator, so these two guys will get cancelled. So we are left with I'll just try to write it down here. We are left with c square plus a square plus b square minus c square, I'm again running out of space, minus c square divided by 2, and if you just take the least common multiple, it's going to be 2c square plus a square plus b square minus c square, which will be c square plus a square plus b square divided by 2, and this all of that is equal to a square. So just cross multiply both sides. We are left with 2a square is equal to a square plus b square plus c square, and I think it should be immediately obvious to you that this will now become a square is equal to b square plus c square. And this means, what this means is that we are dealing with a right angle triangle which is right angled at a, and therefore a is equal to 90 degrees. So you saw that we solved this problem using a two-step approach. We started with our initial goal and we started with the projection formula, and then we got a form which had quadratic terms like a square, b square, like that, and also plus ab cosine of c term. So we applied the cosine rule and then we simplified the expression. We got a square is equal to b square plus c square, which implied that we are dealing with a right angle triangle. So I think it's important to highlight the approach. We are following a logical approach and referring to our toolkit, and we are not rote learning or using any kind of special tricks. So I think you'll appreciate this, and there are a lot of interesting problems, and I'll see you in the next video. So bye.